All right, so building on like our rational expressions, we did multiply, divide, add, subtract, rationals, fractions, common denominator. So you might have heard the expression, don't judge a book by its cover. Many of the expressions you will encounter today appear complicated, but you might be surprised by the techniques involved in simplifying these expressions. They're very familiar, okay? As you consider each expression, keep your eyes open for opportunities to use properties of exponents, substitution, the giant one, right? Enjoy the algebraic merriment that ensues. Okay, these lessons start off with complex fractions. So a fraction that is a complex fraction is when the numerator and or denominator also contain a fraction. So it's like a fraction within a fraction. Okay. That's what a complex fraction is, but it's the same process. So 320, Garrett wants to simplify the complex fraction, but is overwhelmed by the fraction within a fraction. Work with your team to help Garrett write an equivalent expression that is a rational expression instead of a complex fraction. Okay, so we just got to get rid of these fractions within a fraction, right? So talk me through this. How would we do this? Kind of. Close. If we want to get rid of a fraction within a fraction, okay, same thing we kind of did in the previous lesson is we need to just worry about numerator or just worry about denominator, and then we'll finish the other part. So in order to do this, what would we have to do? Just the numerator. What would we have to do? Yeah, so common denominator, right? So we're going to multiply this fraction by x plus 2 over x plus 2, and that gives us a common denominator, right? So 7 over x plus 2 plus, I'm going to go ahead and distribute 3x plus 6 over x plus 2. Right? So then we can do what? Yeah, we can add the fraction, right? Don't worry. We're not worried about denominator yet, right? We can add because we have a common denominator. Right? So now we would have 3x plus 13. Is that right? Over x plus 2. Okay, let's look at the denominator. What would that be? Same thing, right? Same thing. We need this to have a common denominator, right? So we multiply by x plus 2 over x plus 2. Distribute. I will get 8x plus 16 minus x over x plus 2. Now common denominator is there. So what does this become? 7x plus 16 over x plus 2. Okay? Did we get rid of this craziness? Yes, right? But now what do we have? Still have a fraction divided by a fraction. What do we need to do? Okay? So this will stay the same. 3x plus 13 over x plus 2. times the reciprocal, x plus 2, over 7x plus 16. What happens? X plus 2 cancels. Good. So what do you have? Awesome. Okay, so the next one here, same process. Okay, same process. Now, help me out though. Help me out with common denominator here. What do we got to do? What's going to make this one a common denominator? What do we need? Yeah, you need a 3. Definitely need a 3, right? How many x's are here? 2. How many are here? So we need another one, right? So 3x. Does that make sense? So what does this become? 12x over 3x squared minus 5 over 3x squared. Common denominator? Yes? Okay. What about the bottom? 8 over x squared plus 6. What do we need? X squared. So this will be 8 over x squared plus 6x squared over x squared. Okay. Add it up, we get 12x minus 5 over 3x squared over 6x squared plus 8 over x squared. Now what? Same process. Now what? Okay. So stays the same. Multiply, reciprocate, right? So x squared over 6x squared plus 8. What can you do? Cancel x squared. Good. Just x squared. What does that leave me? Over? Good. And you can distribute, but is it going to help you? Like, is it going to get you this? No? Okay, so doesn't really help us to distribute that there. Okay? So,
Yeah.
all right, look at B. Okay, what's different about B? It's exponents are negative. Okay, great answer. Exponents are negative. So what does that do? How can we make that similar to what we've just been doing? Yeah, make it 1 over x, right? So this would be 1 over x plus 8 over x plus 1 over y squared. Good. Good. Okay, so negative exponents, right? Make it a reciprocal and it makes the exponent positive. Good. Okay, so now what's common denominator for the numerator? Common denominator for the numerator. What do I need? I need an x. Common denominator for the denominator. I need a y squared. Good. All right. Speed this up a little bit. 1 plus 8x over x. Xy squared plus 1 over y squared. Right? Multiplied by the reciprocal. Anything? Or anything canceled? Can't, right? Because 1 plus 8x, right? Addition, it's all together. Right? So nothing cancels. Okay? All right, so let's look at this. 22 says this, using substitution to simplify expressions. Okay, so what do they mean, right? So we have someone attempting to factor this, but they think the exponents are confusing. Okay, so looking at this, why would the exponents be confusing if they're trying to factor? What are we used to? We're used to x squared plus 3x minus 2, right? But in this case, it is 6 and 3, right? So, are the exponents a little bit confusing? Sure, right? So part A says, we got a teammate that suggests writing the expression as 9u squared plus 3u minus 2. So they said, all right, we're going to rewrite this as 9u squared plus 3u minus 2. Okay, and then they said, all right, if this is equivalent to this, what does u equal? What does u equal? These are the same. What does u equal? X
Squared.
cubed. 3u, 3x cubed, right? So u is x cubed. If I squared x cubed, would I get 6 to the 6th? Yeah, sure. Sure. Okay, so u is x cubed. Good. Now it says factor this. Okay, so we're going to factor with the u, right? So 9 times 2 is 18. Factor to 18, let's subtract a 3. 6 and 3, right? So I'm doing guess a check. So this will be a positive 6 and a negative 3. Okay, now again, if you're box method or any of those other ones, right? Mass product, slide divide, whatever it is for you, you should still get that. Okay? Now, replace u. So what is this? If I replace u, what do I get? 3x cubed minus 1, and then 3x cubed plus 2. So these are the same, right? So that's how you factor with u substitution. So if something's confusing to you, you can make it u, factor it like you normally would, and then replace it at the end. Okay? So it says this, the letter u was used in the previous problem. It is the traditional symbol used for substitution. If you are making several substitutions and you have already used U for one, guess what they'll use for the next one? For the next letter to substitute. V, right? Like, duh, sure. Okay, and then if you used V and you need to substitute again, then you would go to W, etc. Right? So, all right. So let's try this. Okay. So here's what I want you guys to do. I want you guys to attempt to do this for A, B, C, and D, and we're going to put them on the board. So A, like, what would be your substitution for A? What would U be? What would U be here? Cosine of X, right? What would U be here? Yeah, the whole 4x minus 1, right? Because that would be U squared plus 12U plus 20, right? What would U be here? 7x, right? 7 to the power x. What would U be here? Yeah, x to the 4/3, right? Yes? Go for it. I want you to guys try those. Pick one. Try it. When you get it, we're going to put it on the board. Go.